Assalamu alaikum. Today our topic is about intensity of wave. So intensity of wave is something that can be defined as the rate of transmission of wave energy. Okay, till now we have studied the types of wave and the wave function, and but today we are going to study that wave which is as energy. What would be its rate of transmission? Okay, so rate of transmission of wave energy per unit area is called intensity of wave. Is called intensity of wave. Okay, here the rate in physics, I already told you that rate always mean that when you measure something related to time. So when you measuring something according to time, this is called rate. Okay, and per unit area, here we know we have to consider the per unit area as the spherical area. Why? Because whenever energy is transmitting, okay, it covers the area in the form of a sphere. Okay, definitely whenever in sound, whether it is sound energy or whether it is electromagnetic waves, when it is transmitting, the area which is under focus, which is the area which is under focus, or the area which is covered under the wave, it is spherical. Okay, so definitely area here would be 4 pi r square. So the formula would be intensity is equal to rate of transmission of wave energy, rate of transmission of wave energy per unit area. So rate of transmission of energy is usually called power over area. Okay, and this formula can also be written as intensity energy divided by time multiplied by area. So its unit is equal to watt per meter square, and it is intensity is a scalar quantity. Keep in mind that it is a scalar quantity. So let's solve some questions related to the intensity of waves. Calculate the intensity when a power of 400 watt is received over a cross-sectional area of 20 meter per second square. So definitely the power is 400 watts and area is 20 meter per second square. So the intensity would be equal to power over area, 400 watt divided by 20 meter square. It will come out to be 20 watt per meter square. Next question is that a 100 watt lamp emits electromagnetic radiation in all directions. Calculate the intensity of radiation at a distance of 2.0 meter from the lamp. So the area, we have to first find the area. So this 2.0 meter is actually the radius. Like for example, this is lamp, okay, and it is emitting radiation in all direction. So at a distance of 2.0 meter, what would be the intensity of the light emitted by this 100 watt lamp? So this 2.0 meter is actually the radius. Okay, so the radius, and then we have to find the area, that is through 4 pi r square, because it emits radiation in all, covering a surface area. So the power, this intensity is equal to power over area. So power is 100 watt divided by area is 4 pi r square. So 100 watt divided by 4 multiplied by 3.14 multiplied by 4. Okay, so this 4144 it will become out to be 25. So 25 divided by 3.14 multiplied by 4, it will come out to be 12.56. So intensity as a whole would be 1.99 watt per meter square. So this is the intensity of the 100 watt lamp light at a distance of 2.0 meter. Next question is that the average distance of the sun from the earth is 150 million kilometer. The intensity of the radiation received by the upper atmosphere is 400 watt per meter square. Calculate the total output of the sun. So we need to find the total output of the sun in terms of the power. Okay, so let's solve the question that intensity is equal to power over area. We need power, so the power would be equal to intensity multiplied by area. Okay, so power is equal to intensity, which is given as 400 watt per meter square. Area is equal to 4 pi, or radius is 150. So radius is 150 million kilometers. So 150 million kilometer. So multiplied by 10 raised to power 9 whole square, because this 150 million kilometer for 150 into 10 raised to power 6 kilometer. So definitely if you want to convert this into meter, you have to additionally multiply 1000 with this value. So 150 into 10 raised to power 9 meter will be equal to 150 million kilometer. So after solving this, 400 watt is equal to joule per second. So joule per second multiplied by meter square multiplied by 4 into 3.14, 150 will come out to be 22,500 into 9 to 18 meter square. Meter square will cancel with meter square, and this value will come out to be 1400 multiplied by 4 for 4, it will come out to be 5600 multiplied by 3.14 into 22,500. So 22,500. So when we multiply, the final value would be 3.95 into 10 raised to power 26. When we round off, it is nearly equal, power is nearly equal to 4 into 10 raised to power 26 watt. So a satellite is orbited around the Earth using two solar panels. There are two solar panels for power. The intensity of sunlight received at the height of satellite is 1.4 kilowatt per meter square. The surface or area of each solar panel is 8 meter per second square. Means there are two solar panels and each area is having an area of 8. So 8 multiplied by 2, it will become 16. Total area is 16. Calculate the total energy transferred to the panel in a period of 2 hours. Total energy. So the two solar panels, 1.4 kilowatts, we have to convert this into watt. So intensity is equal to 1.4 into 10 raised to power 3 watt per meter square. And area is equal to two solar panels, 8 into 2, it would come out to 16 meter square. And the time is equal to 2 hours. So 2 hours, we have to convert this into second. So multiplied by 3600, it is equal to 7,200 seconds. So the intensity is equal to rate of transmission of energy per unit area. That is equal to energy over time multiplied by area. So we need time. We actually need energy, sorry. How much energy is calculated? So the energy would be equal to time, intensity multiplied by time multiplied by area. So we are going to multiply all these three values with each other. So energy is equal to intensity multiplied by area multiplied by time. Energy is equal to 1.4 into 10 raised to power 3 watt per meter square multiplied by area is 16 meter square multiplied by time 7200 second. Meter square will cancel with meter square. 16 multiplied by 7200, it will come out to be 11,500 second. 1.4 into 10 raised to power 3. What is we know that watt, which is power, it is equal to joule per second. So we will write joule per second. So second will cancel with second. 1.4 into will multiply with this. It will we get 16 1280 into 10 raised to power 3 joule. Into 10 raised to power 3 joule. So the final value would be 1.6 into 10 raised to power 8 joule. This amount of energy is gained by the two satellites.